What I'm going to show you today is not so much a PowerPoint presentation as it is an interactive PDF. I've just set the PDF to show full screen right now. And so this entire document is clickable, and the facilitators of the workshop have it and can share it with you afterwards. There are many resources and links within this document, so we're definitely not, I'm not going to click on everything. We're not going to go through everything, but hopefully I can give you a little bit of guidance in what's here and a little bit of thoughts on accessing data in course. Okay, so I'll start with a little bit of very quick background and introduction, just because I'm not sure how familiar everyone is. And then I'll talk a little bit about accessing data, both in terms of what we very much think of as, the traditional IODP data, what comes off the ship or off the mission-specific platform or off the CHIQ, as well as the data that gets published later. And then finally, I'll talk a little bit about requesting samples and the repositories. So scientific ocean drilling, at least in the history of this program, has been going on for well over 50 years now. This means there is a ton of data, as well as cores available to the community. And so one of the things I do in my research is try to make use of that. And I think you guys are going to try to do that as well, which is great. Just a little bit of nomenclature. So we talk about expeditions a lot. Those are the 2-month timeframes which the coring and the drilling and the logging actually takes place on board the vessels. Back during DSDP and ODP, we referred to these as a leg instead of an expedition. So those terms are equivalent. So if I say that word, I mean the same thing. Expeditions are generally numbered sequentially through time. During this last IODP phase, we get particularly a little out of order with our numbers through DSDP and ODP. It's fairly reasonable. And so you'll start to see some of the links that are available here. All of these will take you to further information on each of the platforms, give you a little more about the JR, etc. Like I said, we're not going to click on each one of these, or we'd be here for about 5 hours. So all of this material that we've been collecting for the last 50+ years, where is it? It's housed primarily in one of 3 repositories around the world. The Bremen Core repository in Germany has the cores from the Atlantic and the Arctic and the Mediterranean. The Gulf Coast repository here in College Station has the Pacific Ocean, the Gulf of Mexico, and the Southern Ocean. And the Kochi Core Center has the Indian Ocean and the western edge of the Pacific Ocean. And I think Yusuke is going to talk a little bit more about that in just a little bit. Our cores are stored in what we call reefers, but it's basically a giant walk-in refrigerator. This is to maintain the integrity of the core. If you leave out a big wet piece of sediment, it's likely to mold really quickly, and organic compounds, etc., will degrade. So everything's stored about the temperature of your refrigerator, with the exception of microbiological samples, which are archived in a -80 freezer. The repositories also house all of the sample residues from the cruises. So any samples that were collected and run shipboard, those residues have gone to those repositories. Any returned samples, when people request IODP materials, if you're done using them, we request that you don't become your own repository, you send them back to the repositories. And thin sections as well are also stored in the repositories and can be loaned out for use. So I like to talk about data, but people really like to think about samples a lot. So I thought I'd just mention a little, what is a sample even? When we collect samples from cores, we generally have them requested and collected from what we call the working half, which I'll show you in a diagram in a moment. Sample size and type is really driven by the analysis you have planned. And so it's pretty important to think about that if you're going to be making a sample request. And beyond that, Volume is far more important than shape. If you've ever seen pictures of IODP samples, like some of the ones below, this is what you think of. Volume is far more important unless you're in a sort of rare case of an oriented sample, such as a paleomagnetic cube or a micro CT sample, for example. So just keep that in mind when you're thinking about sampling. In terms of legacy core quality, of course, as time passes, from when we collect the core, it can become degraded, it can become dried out, it can be damaged in shipping. And many of the older cores are also heavily sampled. The picture I'm showing you here, all those very white-looking areas are actually foam that's used to replace material when we take a sample. So you can see this particular section has been quite heavily sampled. I think it's from somewhere near one of the PETM boundaries. And so as I mentioned here, this becomes particularly important if you're thinking about boundaries. We like to investigate them, right? But if you come up with a project that says, I want to go look at all of the occurrences of the PETM that we ever drilled, you may find that there actually is no material left because the scientists that sailed on those cruises were, of course, very interested in that material as well. Right now, the Kochi Core Center is developing a database of current core images. And I say current core images. These are not the images from the ship, but they are this picture here. This is an example from that database. Of the current status of the core, sort of how much material is remaining. And it's super useful. And they have a lot of them in there. They don't have all of them in there. I know they're still working on it. And I know the 2 other repositories may soon develop similar databases just because it's such a useful tool when you're trying to go back and sample some of these materials. And as I mentioned, I'll just briefly mention the parts of a sample ID. When you go to request samples, and as you're working with samples, if you're working with data, however you're working with material from IODP, this is something really important to keep attached to whatever data or physical objects you have, because this is really the only way to track where something came from. And so for all the material we recover, if we don't know where it came from, it's not very helpful anymore. And so we keep track of the expedition, site, hole, which core it came from. When we cut a core on the catwalk, we cut it into 1.5 meter long sections. Those sections are then split lengthwise into an archive and a working half. And then the working half is where you generally request your samples from. I'm not going to waste any more time here going into detail. If you were to click on this little box here, it will take you to a YouTube video that will give you a lot more detail, stepping you through this diagram bit by bit. All right, so that's all I wanted to say to get started on the background. I'm going to actually start over here on the right. No, that's not the way we normally read, but I'm going to start over here on the right in data, because if you're trying to pick out, material or data or cores that you want to look at for a legacy project, that's really where you've kind of got to start. And beyond that, I don't know who asked the question, but it was a great question. Can we make projects just out of data? That's what I do. I haven't requested a sample in years now. I just published a paper on something I had collected no samples from. So there is just an abundance of data that has really not been used to its full potential yet. And so I think that's a great opportunity. So in terms of data, I'll start kind of at the beginning. We've mentioned site survey data here a couple of times now, so I'll go in there. In IODP currently, before any site is drilled, you need site survey data to drill there. And so for all of the recent expeditions, that data is stored in the site survey database. This is based at Scripps right now. So we're hopeful that maybe in the future it's going to be published into Zenodo, which is an open, fair database. But for right now, it is still available through the Scripps data bank there. You can use a bit of the advanced search to kind of drive around the globe if you're not sure what you're looking for. A lot of what you'll see in there is done by proposal number, so you may have to do a little bit of sleuthing to find what you're looking for. And then as you go back in time, you'll find, of course, less and less data. During DSDP, there were a lot of sites that we drilled without seismic survey data. But through ODP, that's also available in the digital collection there at the Site Survey Data Bank. Okay. So I've split up data here into two pieces. There's shipboard data and there's all the publications. When I embark on looking at a legacy project, I generally start at the publications because I need to know what were we actually doing? What were the goals of the crews? What did they recover? And so publications are split a little bit by which phase of the program we're in. So I'm going to start most modern and I'll work backwards. Current IODP publications, it's a very nice web page, very easy to navigate. You can quickly jump to everything from the scientific prospectus, which is written before an expedition, all the way through the proceedings volumes, which is produced 1 year after the sample party or the end of the expedition, basically at the end of the moratorium period. It's also got a lot of links to bibliographies, RIS documents, etc. Another really great website, and I'm pretty sure this is run by AGI, is the Scientific Ocean Drilling Bibliographic Database. And within there, all you need to do is say type site U1417, and it will pull up not only all of the reports that come from the ship, but it will pull up any papers, abstracts, theses that are associated with that as well. So when you're really trying to learn more about it, that's a great resource to start with. So after each one of sort of the intro pages, I've included a page called Archive. Because of the way things are going with the program right now, we're not sure how long each of the first websites I show you will stand up. So I want you to be aware that there's a backup plan for everything. And so the current program is being archived in the Internet Archive and the Library of Congress. These are free to access. So even if you go to click on this website one day and it's magically gone away, have no fear, you can click on these websites and get to the proceedings as well. Pretty similar for ocean drilling program as well. Preliminary reports, scientific results, going to that database, and everything once again is archived. ODP is also archived at the Happy Trust. DSDP, similar, just on a different webpage once again, but you can get to each volume this way. And you can always access these also by going to the current TAMU, Texas A&M JRSO publications webpage. You can get back to the older ones as well. And once again, those are all archived as well online. So that's publications, which is really where I like to start when I'm going to dive into an expedition or site that I'm interested in. Beyond that, the next thing I'd like to do is look at the data. And so I'll start here with IODP shipboard data. I note here that this is JOIDE's resolution because IODP shipboard data includes MSP, mission-specific platform data, and CHICU data, which are in different databases that I'll show you briefly in a second. We'll start with the one that maybe most people have encountered at some point. So this is LIMS. This is the Laboratory Information Management System. And so this is where all the most recent expedition data is stored. If you go back to the beginning of around 300, there's a few very odd ones where some of the data is in there, but some of the data is actually in a separate database called the Janus Web Database. This is the database that precedes LIMS. It was used during ODP. So if you're looking particularly into any of those expeditions that are at the very beginning and you don't see what you're looking for, you may just want to jump back over to the Janus web database because it might be in there. Operational data from DSDP and ODP has been transferred into LIMS. However, the scientific data has not. So just sort of keep that in mind. There is a feature of LIMS called the LIMS overview. And I rather explicitly don't show it here because while it is great for looking at data from IODP, it is less reliable the older you get, particularly for DSDP, because that data was never imported into these particular databases. So if you were to use the LIMS overview and go to an expedition and look to see if they collected carbonate data, you would think they didn't, when in fact they did. So just beware of using LIMS for older DSDP and ODP materials. I will show you how to get to those separately. Logging data that was collected during IODP is available through a portal at Columbia University. So you can get all of that there. I've popped a bunch of these link boxes over here because LIMS can be a bit overwhelming when you first go in there. It is not necessarily intuitive about what's there or how you access it. So I've left several resources here. The overview diagram will tell you a little bit more about what data is in there, what type of instrument it's collected with. There's another YouTube video that's an entire tutorial on how to click through, access the data, download the data. And then there's some additional ones on if you're looking for previous samples you had or you know of samples someone else took, and then a little bit about alternate depth scales. So these are just some of the ones that come up most commonly. If you think of questions or have ideas for other ones, I'm always making these based on questions I get. So I'm happy to add to this pile as well. Sort of similar to how the publication site is organized. After you go through the data set for each one, there's a slide showing you where the data is archived long-term. And so scientific ocean drilling data is primarily archived at NOAA. It used to be called the NGDC, but now it's the NCEI, National Centers for Environmental Information. And so they actually house not only IODP, but all the previous programs as well. And you can access that data online. It's very easy. They're not entirely caught up right now with IODP, which is not a big deal because LIMS exists. They'll get it online soon, I think. One sort of important thing to know, though, about NCEI is that the high-resolution TIFF images of the core photos, while archived there, are not available online due to their large volume. And so right now, you can simply go get the images from LIMS. What's going to happen in the future with that, we're not entirely sure. One possibility is Zenodo. There is already an IODP community page, and we are working on transitioning the content of LIMS into Zenodo, which is a fair data repository. Some expeditions, of course, are still pending because they're in moratorium. Some of them are just because we've started in about 2001 and we're working backwards. So you'll slowly see data start to propagate there for all the expeditions as well. Lamont has also got the downhole logging data moved over to Zenodo as well. So those are all backed up there. Before we leave IODP, I'll show you really quick mission-specific platforms. So these are run through eCord, so they're in a different database. They're in Pangea, which is another data repository for georeference data. And you can simply go to the Pangea page, but I sort of prefer using the portal that the Bremen Core repository built. You'll sort of see, if you go to the web page on the left over here, you'll see a drop down of each of the expeditions, and then it's really easy to just click on data. Pangea happens to be really big, and I struggle to find the mission-specific data in there without just using this excellent resource that the BCR built that really sort of just drives you straight there. And CHICU data is also in a different database. This is managed through Jamstech. And when you go on that web page, you'll see for this particular expedition, these were the holes they drilled. And when you want to access the data, you're just going to click on the little check mark. And that will take you either to the regular database data or the images or the logging data. And keep in mind that for mission specific and for CHICU, those publications can be found just through up here. That's why that's not separated out for them. Okay, so if we can take one step back further into ODP data. So ODP data is housed in another database that I mentioned called the JRSO Web Database. It looks, of course, a little more simplistic, right? It's not quite as overwhelming as LIMS to use. It does have all of the core images within it. You can also search by data type. There's a lot of different types of queries, but it's very intuitive and very easy to use. And you're looking for ODP data. Logging data, once again, is available through Columbia. In terms of archiving, once again, the ODP data is available right now at NCEI. It's very easy to access, very easy to get to, very easy to download. ODP data that comes from JANUS, which is a database we manage here at TMU, may be deposited into Zenodo in the future, but that situation is still a little bit unclear, but the logging data is already over there. And I'll add one more thing about Zenodo. One thing that's pretty nice about it is if you are publishing a manuscript with your data that's related to IODP data, you can ask for it to be linked to the IODP community. And so there's just a little button for that. And then that makes a cross-link and helps your research become more visible by being connected with that community. DSDP data, there is not particularly a portal that it's kept in here at Texas A&M. The place that I go for that data is the NCEI. The only sort of caveat to that is, of course, the core images, which NCEI does not post due to their volume. Right now, DSDP core composite photos are still available in JANUS, as long as JANUS is standing upright. And to me, this is something that's really important when you are trying to look up and figure out what you're going to do with something. You just want to see a picture of it. And I don't want to have to email someone at NCEI and wait 2 days for them to get back to me. So when you're going to go look for the images, you can just jump over to the JANUS database right now and look at those images as well. There's a little bit of sort of expedition site whole core summaries that are necessary to support having those images in there, so you can find that data as well, but it's easily accessed at NCEI. Of course, the primary resource for DSDP is also the archive. Right now, DSDP is definitely not being moved to Zenodo, but we are considering moving the core composite images for the reasons I just mentioned. Okay, so that's data. And there is so much you can do if you just stop there and just take a look at the data. You can make an entire project out of that. But if you want to keep going and now you've figured out where you would like to get some material from, you've plotted up some shipboard data, some data from old papers, and you've come up with a new idea, but you need some new samples for that, jump over to the left and look at actually requesting samples and looking at core material. For requesting samples, everything is meant to be accessible to the scientific community. That's why it's there. In return, when you get samples, you incur certain obligations to publish your research. And I've left a link here to the IODP sample data and obligations policy. We've got a pretty brand new, not absolutely brand new, but fairly new portal for that now, the Sample Data and Research Request Manager, SDRM. And so when you go to this website, if you've never been there before, you just make an account. It's quite easy. And this is where you would submit any sample request. We're not going to practice submitting a request. This new software is really nice. It is incredibly intuitive. If you ever had to use the old one, it was pretty painful. This one is great. There's nothing really confusing in there, but we also have a user guide available for it. And you can also get to that within the software. But when you go to generate a request, what you need to have prepared for at that point is what type of request you're going to be making. Maybe most of you fall into the category of a research request, but sometimes we also have requests for material for education purposes. So that's one choice. You'll just click at the beginning. You'll, of course, need to know what leg or expedition you want material from. You'll need a title for your project, and then you'll need a 2,000 word or less summary of what you're actually going to be doing with this material. You'll, of course, then also need a sample list. So these are the very specific intervals within core sections that you would like material from. And then some other basic info like your contact and shipping information. There's also mechanisms for uploading additional files if there's something else that you need to share with the curators. So I mentioned kind of at the beginning of the talk that volume is more important than shape. And so the sample size itself will vary by what type of analysis you're going to do. If you're going to look at a nanofossil assemblage, I need a very small sample. If I want to look at some very rare biomarkers, I need a lot more material. And so when you go to submit a request, IODP sample requests are based on volume. So CC or centimeter cubed. And you really want to request the correct volume of material that's needed for your analysis. As I showed you in that other picture, the material remaining in legacy cores can often be quite limited. So you don't want to request too much. You don't want to become your own repository, but you also don't want to request too little, and then you can't actually make your analysis. So I did dump a little calculator into this thing. You'll need to kind of take a gamble on the density of your material, but if I know for what I'm going to put in this particular instrument, that I need 40 grams of material, and it's my bad. Oops, daisy. Like I said, I've never practiced before. Okay, so then I need 24 cc's of material. I've also added a little diagram over here just because I'm a very spatial person. And so thinking about what that actually looks like in the real world helps me a lot. When we collect cores, if we collect piston or XCB cores of softer sediments, the liner will be completely filled. If we rotary core, which is RCB, the liner will not be completely filled. So that's why you see a little caveat there for the volume you would expect from a rotary drilled core. But in general, if I was to take all the material from the working half over 1 centimeter, I would have taken 17.5 cc's worth of material. Sometimes for some analysis, people know better sort of what a hand-sized piece looks like. If you're just depends on the scale you're sort of working on. There's a link here that will show you a lot more about sample sizes and sample types that we traditionally use. But this is something that you will need to enter when you've got that sample list ready to submit. Of course, we'll need to know what expedition, what site, what hole, what core, what section, but we need to know what volume of material you need. Okay. In terms of repository facilities, some measurements can be made on cores at the repositories. In particular, all 3 of the repositories have XRF scanners, and you can make that request through the SDRM system. Beyond that, other equipment varies kind of a great deal between the repositories. For XRF scanning, you submit your request there, but I would encourage you very strongly to be in contact with the curator of whichever repository you're going to go to. You'll need to find out what's available, what their schedule is like. for the time you're thinking about going there, and there may be a cost associated with using any of their instrumentation as well. So I've left you a slide with links to the websites for each of the repositories, links to the email addresses for the curator, a little bit about the instruments that are in H1. I'm not going to talk about Kochi because you're going to do that separately in a minute. The Gulf Coast repository right now has XRF scanner and the image scanner. But the equipment that is on board the JOIDES resolution is owned by Texas A&M University, and will be coming back here and will be set up starting in the fall of 2024. So there are going to be some significant coming changes to what we have available here. So stay tuned. Okay, so that's everything that's in this particular interactive PDF that your facilitators will share with you afterwards. I think I've got a few minutes to show you one or two other things, if that's okay, Myra. I can't see anything.
Yep, no problem.
Okay, thanks. Okay, let's see if I can do this. Okay, can you see a different presentation now?
Yeah, it looks nice and colorful.
Okay, good. All right, perfect. So I'm just going to show you a couple of other data access tools. They're not as formal as what I just showed you, clearly. I always tell everyone, let this be a lesson to you, that when you buy a domain name, just pick carefully, because you might get stuck with it for a really long time. And then once people know it, you really can't change. So this is a website that I've built myself. This is not official IODP endorsed material, etc. And what it is a series of small web applications that allow you to explore some of our data. And so this is kind of all over the place, built on what people have needed. This covers things like outreach, if you want to find all the videos that were ever collected on board. I have this awful thing called a database of databases, and it's a version of what I just showed you in the PDF, but it allows you to click through and get to the NCI website, to the archive websites of the older programs. And then some of them are quite simple. I'll show you real quick this one called Scientific Ocean Drilling Map. This is the one that I made for myself and I use the most. And so when you go to that page, you'll see a big map. All of these colors are the different programs of scientific ocean drilling. And you can filter which dots you see. You can toggle the programs on and off. You can toggle the expeditions on and off, only see the ones you want to. Maybe you're only looking for shallow water sites. You want deep penetration sites. If you have a specific site in mind, you can also type it in and pick it. I've picked one of my own that comes from off the southern end of New Zealand. And you'll get this table that will show you where it is, how much core. And importantly, on the far right column there, it will tell you which repository it's in. There is no other good place to see that I have found. And I'm just zooming in here to show you that all the holes are really there. This helps to give you a sense of when we say there's a site and there's these holes. This is how far you have to zoom in on a global map to see the difference between hole E, hole C, and hole B. So feel free to play around in there. It's got some little graphs it'll make for you at the bottom if you kind of want to see what types of coring they used on a particular expedition, things like that. Okay. Another thing I'll point out on this website over here on the far right is a section called Lily applications. And this is obviously kind of new because I haven't even quite gotten to this one yet. So Lily is a database that I just published at the beginning of this year. And what it does is it takes all of the shipboard data from 42 expeditions, it spans 10 years, and adds the lithology. If you were to think of a spreadsheet, just adds a column that gives you the lithology. So you can look at the data in the context of knowing what type of material you're actually looking at. You can also just look at the lithology itself. We've spent a lot of effort making this consistent across expeditions, clearing up misspellings. There weren't a lot of guardrails on some of the previous software, so you could end up with sand with 2 S's and all capital sand, and sand with capital S and lowercase sand. And so all that's really been cleaned up to make the data more accessible. And so each data type is just a single easy to access CSV file. And that file for a data type will contain all 42 expeditions, and you can get to them at Zenodo at that link there. This paper is also open access, so please go have a read. It's available to everybody. And so on Shiny Laurel itself, there's a little bit of background about the types of data and things you can find. The one app I've managed to get running so far is the lithology search. And so as I mentioned, this covers 42 expeditions. These are the 42. And so, but even if you want to look at something older, this is maybe a great way to look at trends of a certain type of material. So I just picked the ones around Anzac. I'm going to say I'm interested in nanofossil ooze. It is, you type, but then it'll start helping you fill in. So you don't have to guess what lithologies exist in the database. I'll get ooze and chalk just because they're kind of similar. I hit search and it will spit out every single section, as well as the intervals within it where there is nanofossil ooze or nanofossil chalk. And so each of the prefix, principal, suffix searches are independent of each other. So you can put a ton of different terms in, and then you can just click the download results button, grab that out, go run over into Excel or Python or R, whatever you like to work in, and explore that further if you're trying to look at some data. So that's just sort of one of the quick ones I've made. You can also use the actual data from Lily to try and explore questions before you maybe are actually submitting your proposal. Even if the expeditions you're interested in aren't in that database, because it is so big, it can sort of show you generalized and global trends for different lithologies and different data types. So I've made up a very fake question here of, do sediments become compacted at depth? Of course, we know they do. But we can grab the data in the Lily database and we can look once again in our nanofossil ooze and our nanofossil chalk, and we can say, yes, sure enough, as we go deeper, not only do we see the transition from ooze to chalk, the density is increasing, and simultaneously the pore space is decreasing. So that's just a very silly example of one of the things you can very quickly plot up. Once you pull this data off Zenodo, making a graph like this will take you, 5 minutes instead of having to go and grab all of that information from a lot of different places. Okay, so that's all I had. Feel free to email me anytime if you have questions about accessing data or accessing cores. I may not be the right person to ask, and that's completely fine. I will just send you right on to the person who is. So please don't hesitate if you need anything.